Okay, today we're going to look at an arithmetic series. Arithmetic series is the sum of an arithmetic sequence. Okay, so if you have a sequence or if you have a series, that just means you're adding together the numbers that are in a sequence. So for example, if you have a sequence like 2, 6, let's see, we're adding 4 each time, so 10, 14, etc. This is a sequence. But on the other hand, 2 plus 6 plus 10 plus 14 plus etc. would be a series, okay? You're adding them all together. It turns out we have a formula that will do that for us. We just have to substitute the values into the formula and it will calculate the series. The sum of the terms of an arithmetic sequence. The formula for the series is the sum is equal to n over 2 times a1 plus an, where a1 is the first term, an is the last term, and n is the number of terms, okay? Because you have to have a finite number of terms or else the sum would be infinity. All right, so find the sum of the arithmetic series. 12 plus 19 plus 26 plus yada 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 plus 180. So if we look at this, we can see, well, the first term is 12. The last term is 180. The number of terms, well, I don't know how many terms there are here. There could be 30, there could be 40, there could be 100. Okay, I don't know because this tells me that there's just some terms here, but I don't know how many. Okay, so I have to think back to what I know about sequences. Okay, what I know about sequences is that the nth term is equal to the first term plus the difference times n minus 1. So I can use this to calculate the number of the last term because I'll have 180. The nth term is equal to the first term plus the difference, which in this case is 7. 12 to 19, that would be 7, times n minus 1. And I can solve this for n, which is the number of terms. So 12 plus 7n minus 7, just distribute the 7. So 180 is equal to 7n plus 5. I can solve this for n. So minus 5, 175 equals 7n. Divide by 7, n is equal to 25. Okay, so going back to what I need to know for the series, I need to know the first term, the last term, and the number of terms. Well, it turns out that there are 25 terms. 180 is the 25th term. So now I can use the formula to calculate the series, or the sum. N is equal to 25 over 2 times A1, which is 12, plus AN, which is 180. 25 over 2, that's 12.5. 12 plus 180, well, that's 192. Multiplying these together, 12.5 times 192 is 2400. Okay, so adding all of these terms together, the series is 2400. Now there's another way that you may see a series. You might see a series as summation notation. Okay, summation notation looks like this right here. It has a big E, it has a number on the bottom, a number on the top, and then a formula, in this case 5n plus 6. This is just another way of looking at a series. Okay, what this series says is that it's a series from 2 to 10 where each term is 5n plus 6. Okay, so for instance, I have 2 to 10, so 2, 3, 4, 5, 6, etc., 10. Okay, so this would be the 10 term, well, no, here, let me try that again. I would have A2, A3, A4, etc., all the way to A10. Okay, so there's 10. So the first term is A2, the 10th term is AN. How do I find each of these? Well, I would just substitute numbers 2 through 10 into this formula, 5n plus 6. If you plug in 2, 5 times 2 is 10, plus 6, so A2 is 16. If you plug in 3, so 5 times 3 plus 6, 15 plus 6, 21. 21 is A3. Sorry, these should have plus signs in between them, actually. Because it's a series, so we're adding them all together. So A2 plus A3 plus A4 plus A10. A4, plugging in 4 here is 26, etc. Plugging in 10 would be 56. Okay, so this is the series that is described by this formula. Okay, that's what this says. It says add up all the terms 2 through 10 of 5n plus 6, which is 16 plus 21 plus 26, etc., all the way to 56. Well, we don't need to do it this way. We just need to use the formula. So the formula would be Sn equals n over 2 a1 plus an. Well, here, let me see. So a1, the first term, is 16. It's actually a2 in this case, just because this starts at 2. But a1 just means the first term, and the first term is actually 16. The last term, which in this case is a10, is 56. The number of terms is actually the upper limit minus the lower limit plus 1. Okay, the upper limit is the number on top, the lower limit is the number on bottom. Okay, so the number of terms in the series, n, is 10 minus 2 plus 1. That's how many terms there's actually in this series. So 10 minus 2 is 8 plus 1, so there's actually 9 terms here. To find a1, substitute the lower limit. We already did that. It's a1. To find an, substitute the upper limit 10. We already did that. 10 times 5 is 50, plus 6 is 56. Okay, so let's go ahead and use this information to calculate the series, which is the sum. So n over 2, 9 over 2, times a1, 16, plus an, which is 56. So 9 over 2, that's 4.5. 16 plus 56, that's 72. 4.5 times 72, 324. Okay, so the sum of the series here is 324. Okay, so the value of the sum of the series from 2 to 10 at 5n plus 6 is 324. Okay, that's what this is equal to. It has a value. All right, let's try again. So the sum of the series here from 1 to 100 of 2 minus 3n. The first term, we would just plug in 1. So 2 minus 3 times 1 is 2 minus 3, which is negative 1. So the first term is negative 1. The nth term, or the last term, I would have to plug in 100. So 2 minus 3 times 100, which is 2 minus 300, is negative 298. And the number of terms, 1 to 100. So that would be the upper number minus the lower number plus 1. Okay, so 100, so that's just 100. And that makes sense. If the first term is a1 and the last term is a100, then there's 100 terms. I can use that for the formula now. So n over 2, 100 over 2 times a1 plus an. So that's 50 times negative 299. So let's see what that is. So that's negative 14,950. Okay, so that's the value of this series, negative 14,950. It's the value of that series. Now, sometimes you might have these problems given to you as word problems. So, for example, a stadium has 20 seats in the first row, 23 seats in the second row, 26 seats in the third row, and so on. There are 90 rows. Okay, so it looks something like this, 20, and then it says how many seats are in the stadium. So that's all the seats added together. It'd be 20 plus 23 plus 26, all the way to the 90th term, whatever that is. I don't actually know what the 90th term is here, so I do have to calculate it. So remember how to calculate a specific term. A sub n, an nth term, is equal to the first term plus the difference times n minus 1. Okay, so the 90th term is equal to the first term 20 plus the difference, which is 3, times n minus 1. N in this case is 90 because there's 90 terms, so 90 minus 1. So 20 plus 3 times 89. So let's see what that is. So 3 times 89 is 267, plus 20 is 287. So this is 287. So this number at the very end here is 287. All right, so now I have enough information to determine the series. Okay, so the first term is 20, the last term is 287, and the nth term, or sorry, the number of terms, which is 90. Plugging all of that in, so the series is equal to half the number of terms, 90 over 2, times the first term plus the last term. Okay, 90 over 2, that's 45. 20 plus 287, that's 307. And then we calculate 45 times 307, 13,815. So that's how many seats we have in the stadium. And that just represents the series.